Hey everyone, and welcome back to Pod 4 Journal Club, where we break down the most fascinating new research. Today, we're diving into something that really gets to the very heart of what AI is and what it could become.
You know, we've all seen the incredible things AI can do, right? It can paint pictures, write poetry, even churn out code. But is that thinking, or is it just really, really good pattern matching? That's the big question. The real frontier here is reasoning. Can an AI actually think with the abstract logic of a mathematician? Well, that's exactly what a brand new research paper aims to find out. They've created something called MathNet, and you can think of it as the ultimate gauntlet, a global test designed to push the world's best AIs to their absolute limits on mathematical reasoning.
Okay, so you might be thinking, hang on, don't we already have tests for AI math skills? And yeah, we do, but it's not that simple. See, the problem is most of the current benchmarks are just too narrow. They're often in just one language, or they only test a tiny sliver of math. The paper uses a great analogy. It's like trying to judge a virtuoso pianist by only having them play Twinkle, Twinkle, Little Star. You're not getting the full story, not even close.
And this is where the paper gets really, really interesting. It focuses on a very specific skill called math-aware retrieval. Now, what is that? It's not just about crunching numbers to get an answer. It's about something deeper. It's the ability to see two problems that look totally different on the surface and realize they're actually the same exact mathematical idea underneath. This slide is a perfect example. A truly smart system would look at the first two equations and go, yep, that's a circle, and that's also a circle. The variables are different, but the core concept is identical. But it also needs to look at that third equation and know, whoa, that's not a circle at all. That's a straight line. And here's the kicker. This is exactly where current AIs often trip up. They get distracted by the superficial similarities and miss the deep structure.
So, to really test this new kind of reasoning, the researchers knew they couldn't just download some existing tests. Nope. They had to build their own arena from the ground up, and they went big.
How big? We're talking over 30,000 problems. And listen, these aren't your high school algebra homework. These are Olympiad-level problems, the kind of stuff designed to stump the most brilliant human minds on the planet. And to make sure it was a fair, global test, they pulled these problems from national math competitions in 47 different countries. And get this, they're in 17 different languages. So the AI can't just be good at English math, it has to understand the concepts no matter how they're written.
I mean, just look at this map. It really shows you the sheer scale of what they put together. They've got problems stretching back 4 decades. This isn't just a data set. It's a historical archive of mathematical challenges, built to be as unbiased as possible.
So what exactly is in this gauntlet? Well, it's not just a big pile of questions. For every single problem, you get a high-quality solution written by a human expert. The problems cover over 65 different areas of math, and they're a mix of everything: text, formulas, images, and this rich setup lets them test 3 key things. 1. Can the AI just solve the problem cold? 2. Can it find a similar problem in the massive library? And 3, the really important one, can it use that similar problem to actually figure out the new one?
All right, the stage is set, the test is ready, so let's get to the main event. How did the biggest names in AI actually do? Let's see the results.
Okay, so first up, straight up problem solving. And you can see that even the top models aren't acing this test. Gemini got about 78% right. Now, that's really, really good, but it's not 100%. It shows you just how tough this benchmark is. There's still a lot of room for improvement. But what if you didn't have to solve it cold? What if you could look at a cheat sheet? That's basically the idea behind the next test, which uses a cool technique called retrieval-augmented generation, or RAG. Just think of it as an open book test for the AI.
And it works pretty much how you'd expect. The AI gets a new problem. Then it digs through that whole MathNet library to find a similar one that's already been solved. Finally, it uses that solved example as a kind of template to help it crack the new problem.
So, does it work? Oh yeah, it works really well. When the AI gets the perfect example to look at, its score can jump by as much as 12%. That's a huge boost. It shows that learning from an example is an incredibly powerful tool for these models.
But, and this is the big but, here's the twist. The AI is great when you give it the right page in the open book. The problem is, it's terrible at finding that page on its own. That math-aware retrieval skill we talked about earlier, that's its Achilles heel. It has the library, but it doesn't know how to use the card catalog. One of the things I really respect about this paper is how upfront the researchers are. They don't just brag about their results, they're really clear about the limitations of their work, and that, right there, is the sign of great science.
So they're quick to point out a few things. First, MathNet is a benchmark. It's a ruler. It's not the final answer on AI reasoning. They also acknowledge that, hey, they use GPT-5 to help grade the tests, and that could introduce its own biases. That's why they had humans double-check so much of it. And finally, they remind us that this is all focused on one specific, very creative kind of math, the Olympiad stuff, not every single field of mathematics.
So what's the big takeaway here? Where does this leave us? I think this paper is more than just a report card on today's AI. It's really a roadmap for where we need to go next.
The authors themselves put it perfectly. They say that this weakness in retrieval, it shines a huge spotlight on a fundamental problem in how AIs currently learn about math. Basically, it suggests that just being good at predicting the next word isn't enough. We might need totally new approaches that can actually grasp the underlying logic.
And let's be clear, this isn't just about making an AI that's good at homework. Think bigger. An AI that can truly reason like this, one that can spot those deep connections, that could be a game changer for science, for engineering, for medicine, for any field where we're tackling really tough, complex problems.
So it all comes down to this really mind-bending question. What happens when an AI can do more than just calculate? What happens when it can see the fundamental patterns that connect everything? MathNet doesn't give us the answer to that, but it gives us a much, much better way to search for it. And that is why this research is so important. Thanks so much for joining me on Pod 4 Journal Club. If you like this breakdown, do us a favor and hit that subscribe button for more deep dives into cutting-edge research.